Welcome to the session on embedded systems. Today we are going to discuss about the software programming concepts in embedded systems. When we come to the programming concepts, we have programs written in high-level language, we have programs written in assembly language, we have several languages where we can code your embedded program. So first, let us discuss about the high-level languages. When we come to a high-level language is a programming language that are more or less independent of a particular type of computer. Such languages are considered as high-level languages since they are very closer to human languages and farther from machine language. Examples of high-level language could be your C, C++, Java, C Sharp, and etc. Next, we have to speak about the low-level languages. Low-level languages are used to write a program that relate to a specific architecture or hardware of a particular type of computer. They are closer to the native language of the computer, that is, mostly they are related to binary language and making harder for the programmers, that is human, to understand. Assembly language are still used for developing code for specialized hardware such as device drivers. So example of low-level language could be your assembly language, machine language. When we speak about the assembly language programming, so assembly language codes are very sensitive to the processor, memory ports, and devices. Assembly software takes precise control of the processor, internal devices, and makes a complete usage of the processor features, an instruction set, and also addressing modes. Machine codes are compact and the system needs only a small amount of memory. Since it requires only a small amount of memory, data types, selection conditions, declarations of rules, it's not specific to that compiler. A compiler program is not compiler specific and library function specific also. Assembly codes for a particular device can be compact and also precise. So assembly language coding follows a bottom-up approach which could be easily usable. First, the basic building blocks are being coded and then it is combined to a bigger module. Next, we have to speak about the high-level language programming concepts. When we come to the high-level language programming, the examples as we see earlier is your C, C++, C Sharp, Visual C++, and Java. The program developed is much shorter in high-level language and it may be complex due to several procedures followed, C++ functions and Java methods. It should include standard library functions and modular programming. As the low-level language follows a bottom-up approach, this high-level programming follows a top-down, object-oriented design approaches. When we come to the top-down design programming, the main program is designed first, which will be splitted into several modules, and each module is all splitted into sub modules if necessary. High-level program facilitates declaration of data types. The type of declaration simplify the programmer from confusing. The high-level language program facilitates type checking. This makes the program less prone to errors. The program facilitates flow control structures such as loops and conditional statements. The portability is very high and it is processor independent. So now we have seen about the high level language and low level language. Now let us speak about the structural elements that should be included in writing a program. So in writing a program, pre-processed declarations and definition of statements are mandatory. A function should be declared in the main function. Functions, exceptions handling, interrupt service interrupt service routines can also be declared as structural elements. The structures also including directives in a file, defining preprocessor global files, definition of constants, declaration of global data types, type declaration and data structures, macros, header, source files and preprocessor directives also included as structural elements. Now let us discuss in detail about the preprocessor directives. So the preprocessor directive include the contents of a file. The preprocessors are includes with the hash symbol. So hash include stdio.h is a preprocessor directive. Another example is hash include adder.c, hash include strip.text file, hash include data_nc.constant. So when we include any preprocessor directive, these files whose codes are already available. Hash include prtc handlers.c. For example, if you want to include constant data files, the extension of these files are .constant. If I want to include some strings and data files, these are the files of strings that I have the extension of .strings or .str or .txt. Example, hash include net any file name .your txt, including data files. So this can also be done in your preprocessor directive. These files are located in the ROM of the embedded system. Your bootup program will be copied later into the RAM that has the extension .init. RAM data files have got the extension .data. Continuing with the preprocessor directive that include basic variable files. Files for the local or global static variables are stored in the RAM. Variables do not possess initial or default values. So including a header files, so it is a preprocessor directive, including the contents of the source files. These files can be used for specific modules. So all the header files will have the extension .h. For example, let us discuss about a preprocessor directive hash include stdio.io.h. Now I have declared a main function. In the main function, I have declared three variables in the int a, b and c. So print f, enter two numbers. I have declared my variable there. Now I'm just going to get the input for a and b, and then I have to summate and put the variable in C. So I'm going to print the result that is stored in the C. Again, I have one more program, the same program, but I have included a comment in the stdio.h. So as we discussed earlier, include stdio.h is a preprocessor directive. So once I have returned this program, I am going for compiling. So what will happen at the end of compiling the program 1 and the program 2? So the program 1 will get successfully compiled and it will print the result of C. So what will happen to the program 2? Because here the preprocessor directive has been commented. Actually, when we compile this program number 2, automatically it will be in .c extension. So when it is in .c extension, the preprocessor directive will be included and the program will be compiled. If this is not stored in .c extension, it will throw an error because this preprocessor directive is not included in this program. Similarly, if we have any math function, then we have to include #include math.h. So these preprocessor directives will have some header libraries which will be read when we compile the program. Now let us discuss about the source files. Source files or program files for the functions of application software. The source file need to be compiled, tested and validated. A source file also contains preprocessor directives of application softwares. The file has a first function which is called main function, from where the processing will start. The code in C for the first function is void main and then int main, and if you want to make an empty void, main void. The main function calls another function if it is included in the main function. So in this segment we discussed about what are the types of languages. So we went to high level and low level language. Then we discuss about the preprocessor directives. A preprocessor directive will start with the hash sign. The preprocessor will give the compiler inputs for preprocessing. So the preprocessor global variables start with hash define. So preprocessor constants, it can be .const. Then we went to source files and header files. The header files will end with .h. The next topic is macros. What is a macro? Macro is nothing but a collection of codes. A macro can be defined in C using hash define preprocessor directive, which we saw now. A macro is a fragment of code that is given by a name. We can use that fragment of code in the program by using the specified name. The macros can be classified into different types like object-like macros and function-like macros. So object-like macros, the first type, syntax hash define variable name. For example, I am going to define an object. Hash define is a preprocessor directive PI 3.14. So wherever I use PI in my program, it will get the value 3.14. If it is a function like macros, then the syntax would be hash define any macro name, argument and code. The parentheses are optional here. If it is present, it increases the readability of the program. So a user can write a program. If another layman, if he reads the program, this argument code will help them to understand. Now let us discuss a macro with the example. So first, I have included a preprocessor directive stdio.h. Suppose my macro name is demo. So define demo. So I have declared a variable for this. Now I have declared a main function. Now I'm just getting a value for n. So demo, within bracket I have passed the value for this x. For now the value of x here is 2 and multiplied with another, this is also a macro, and now the value when it comes here, the value of x is 3. Now I have to print the value of n. So what will happen? Now when it comes here, it will take the value of x as 2. So what is the value? X plus x. So when it runs this, it takes the value of x plus x as 2 plus 2. Then we have a multiplication sign. Then when it comes here, it takes the value of x as 3. So star 3 plus 3. And it will print the value of n in the statement as 11. So here it is without brackets. So it follows your mathematical basic board mass rule. Now I am defining the same example with the same macro but with brackets here. So now I am including a preprocessor directive, that is hash define stdio.h. Now I am using the macro demo and the same as I declared x plus x. Now in the main function I have included a bracket in my macro. So when my function runs, here the value of x is 2. So it will perform, since it is inside the bracket, so the variables inside the bracket will be executed first. So it performs 2 cross 2. When it comes here, so it is 2 cross 2 here, and here it is a multiplication sign, then demo 3. So here when it comes to this macro, it will take the value of x as 3, then it perform 3 plus 3. So finally 3 plus 3, 6, 2 plus 2, it is 4. So 6 cross 4, the answer will be 24 will be printed in this n. So this is how we make use of the macros. So once the macros have been defined, globally we can include in your function. So the next concept in the software programming is functions. Functions are nothing but a set of codes with values of reference passed by calling the program through its arguments. Also returns the data when the function is not declared as void. So the functions are of several types: the main function, recursive function, and reentrant function. In C, the main function is treated the same as every function. It has a return type. The main function executes a set of codes, calls a set of function, calls the interrupts also. The only difference is that the main function is called by the operating system when the user runs the program. The second type of function is the recursive function. A recursive function is a function that calls itself during its execution. So this enables the function to repeat itself several times, outputting the result at the end of each iteration. For example, I have returned a recursive function, so it will be called on repeatedly for each iterations. So the third function, as we discussed, is the reentrant function. A function is said to be reentrant if there is a provision to interrupt the function in the course of execution. For example, I have a program written, so if there is a provision to interrupt, stop and run to some other subroutine, so then that is called a reentrant function. So a function is said to be reentrant if there is a provision to interrupt the function in the course of execution, service the interrupt service routine, and then resume the earlier going on the function without hampering its earlier course of action. A reentrant function is one that can be used by more than one task concurrently without the fear of data corruption. A reentrant function can be interrupted at any time and resumed at a later time without loss of data. A reentrant functions either use local variables or protect their data when global variables are used. Reentrant function has to satisfy certain conditions so that it could be called as reentrant. It may not use a global and static data. It should not modify its own code. This is important because the course of action of the function should remain same throughout the entire code, and it should not call another non-reentrant function. So when we come across an example of a non-reentrant function, so this function is called function 1 and it is not going to return anything, and similarly function 2, so it is also not going to return anything. For example, if it is a reentrant function, so I have included a function, so I have included a variable, so it will return something to the main function. Similarly, if function 2 is called, then it will go and fetch, run this function 1, get the values, go to the main program and gets its value and return. So in continuation of functions, there are several ways of calling a function. A function can be called by its value. It can also be called by reference. So call by value. In this parameter passing method, the values of the actual parameters are copied to the function formal parameters, and the two types of parameters are stored in the different memory locations. So any changes made inside the function are not reflected in the actual parameters of the caller. When it comes to the call by reference, both the actual and the formal parameters refer to the same functions, so that any changes made inside the function are actually reflected in the actual parameters of the caller. There are 4 different types of user-defined functions: a function with no arguments and return value, the function with arguments and return value, function with arguments and no return value, function with no arguments and the return value. So the first type, no arguments and return value. There should be occasions where we may need to design some functions that may not take any arguments but returns a value to the calling function. An example for this is the getCharacter function, which has no parameters but it returns an integer or data that represents a character. So int function, so a function should be called, that is your function within the braces. So we have to define the function as int function, and within that you have to find this, write the statements, and if it returns something, then it returns the value of x to the main function. So this function has no arguments, hence it is called no arguments and return type. The next is arguments and return type. Here in the function I am passing a argument value. So the function declaration is int and the function calling is the function of x. Here int function I am passing a value here. So within that I am writing some statements and returns the value to x to the main function. Hence this is called arguments and return type. When a function has arguments, it receives any data from the calling function but it returns no values. So arguments and no return type. So the function declaration syntax would be void function. Within that I am just giving an integer value and the function is being declared here. So void function, here I am passing the value of x and I am writing some statements and it will not return anything to the main program. When a function has no arguments, it is called no arguments and no return type. When a function has no arguments, it does not receive any data from the calling function. Similarly, when it does not return a value, the calling function does not receive any data from the called function. So the function declaration would be void function. So I'm not passing any values to the function, I'm just writing the statements. So no arguments here and no return type. So normally we have discussed about the macros and the functions. So when we come to functions, we discuss about the several types of functions, And in the next segment, we can also discuss each functions with an example. So macros are pre-processed, where functions are only compiled. The number type in checking is done is macros. Type checking is done in function. Using macros increases the code length. Using function keeps the code length compact and effective. The speed of execution is faster here and the speed of execution is slower. Macros does not check compile errors, whereas the function checks compiler time errors. Thank you.